Let's look at first order differential equations and the method of separation of variables. So the question says find the particular solution to the differential equation 1 plus x squared times dy over dx equals x minus x times y squared at y equals 2 and x equals 0. So we'll start by factorizing the right hand side by taking the x out from both terms. And if we do that, we end up with, in brackets, 1 plus x squared times dy over dx equals 2. So factorizing the x out, we're left with 1 minus y squared. And now if we times both sides by dx, we end up with 1 plus x squared times dy equals to x brackets 1 minus y squared times dx. Now moving all the y terms to the left hand side and the x terms to the right hand side, we're going to divide both sides by 1 plus x squared and by 1 minus y squared. So if we divide the left hand side by 1 plus x squared, this bracket cancels, and if we also divide it by 1 minus y squared, we then end up with 1 over 1 minus y squared times dy equals 2. And so on the right hand side, if we divide by 1 minus y squared, then this bracket cancels. If we also divide by 1 plus x squared, we end up with x over 1 plus x squared dx. Now if we focus on the left hand side, we can rewrite 1 over 1 minus y squared as the difference of two squares. And so we end up with 1 over 1 minus y brackets 1 plus y. Now using partial fractions, we're going to rewrite 1 over 1 minus y brackets 1 plus y in partial fraction form using a over 1 minus y plus b over 1 plus y. Now multiplying both sides by the denominator on the left hand side here, if we times this fraction by the denominator, we end up with 1. And now if we times this first fraction by this denominator, the 1 minus y cancels and we end up with a times 1 plus y. Likewise, if we times the second fraction by this denominator, the 1 plus y cancels and we end up with plus b times 1 minus y. Now if we let y equal to 1, we then end up with 1 equals 1 plus 1, which is 2. 2 times a is 2a. And then 1 minus 1 is equal to 0. 0 times b is just 0. So dividing both sides by 2, we get a equals a half. Then if we let y equal to minus 1, we end up with 1 equals 2. So 1 minus 1 is equal to 0, and 0 times a is 0. And then 1 minus minus 1 is 1 plus 1, which is equal to 2. And 2 times b is 2b. So dividing both sides by 2, we end up with b equals to a half. And so the left hand side can now be written as a half over 1 minus y plus a half over 1 plus y. And if we factorize the half out from both terms, this is the same as a half, and then in brackets we have 1 over 1 minus y plus 1 over 1 plus y. And so we're now going to replace the left hand side of this differential equation with what we have here and also integrate. So this differential equation now becomes a half times the integral of 1 over 1 minus y plus 1 over 1 plus y integrated with respect to y, and that equals 2. And now if we integrate the right hand side, we have the integral of x over 1 plus x squared integrating with respect to x. Now the reverse chain rule is a form of integration we can use to integrate each of these terms. And so the reverse chain rule tells us that the integral of f dash of x over f of x with respect to x is equal to ln of the mod of f of x times some constant k, which we need to adjust for, plus the constant of integration, which is c. So we now end up with a half. Now if we integrate the first term here, this is going to become, in brackets, ln of the mod of 1 minus y. And so to check for the constant in front, which is k, if we differentiate this, this would become minus 1 over 1 minus y. But since we have 1 over 1 minus y, we need to times this by minus 1. So that if this was differentiated, it would produce 1 over 1 minus y. Likewise, if we integrate the second fraction, this would become plus ln of the mod of 1 plus y. And again, we need to check this. So if we differentiate this, we end up with 1 over 1 plus y, which is exactly what we have here. So we don't need to write anything else in front. Now closing the bracket, on the right hand side, you can use the reverse chain rule again. So we now end up with ln of the mod of 1 plus x squared. If we check this by differentiating, this differentiates to 2x over 1 plus x squared. Now since we have x over 1 plus x squared and we have an extra 2 that would be produced, we need to times this by a half. So that now if we differentiate this, it would produce x over 1 plus x squared. And since the original differential equation had y differentiated with respect to x, then when we integrate, we're going to add on plus c on the side where we integrated with respect to x, which is the right hand side here. So we add on plus c. We can now times both sides by 2 to cancel out the halves here. We would now be left with minus ln of the mod of 1 minus y plus ln mod 1 plus y equals to ln mod 1 plus x squared, and then c times 2 would give us plus 2c. And so this can now be written as ln of the mod of 1 plus y minus ln of the mod of 1 minus y, which equals to ln mod 1 plus x squared plus 2c. And so using the subtraction law for logarithms, we can now rewrite the left hand side as ln of the mod of 1 plus y all divided by 1 minus y, which equals to ln of the mod of 1 plus x squared plus 2c. Now if we use our boundary conditions and substitute y equals 2 and x equals 0 into this equation, we end up with ln of the mod of 1 plus 2 over 1 minus 2, and this equals to ln of the mod of 1 plus 0 squared, and then plus 2c. So simplifying this, 1 plus 2 is 3, 1 minus 2 is minus 1, 3 divided by minus 1 is minus 3. So we end up with ln of the mod of minus 3, which equals to, now 1 plus 0 squared is 1 plus 0, which is 1. So this becomes ln of the mod of 1 plus 2c. And so the modulus of minus 3 becomes 3, so we end up with ln of 3. And now on the right hand side, ln of 1 is equal to 0. So we're just left with 2c. Now dividing both sides by 2, we end up with a half ln of 3 equals to c. And now if we substitute this back into this equation, we end up with ln of the mod of 1 plus y over 1 minus y equals to ln of the mod of 1 plus x squared plus 2 multiplied by a half ln 3. And now this simplifies to ln of the mod of 1 plus y over 1 minus y, which equals to ln of the mod of 1 plus x squared. And now 2 times a half is 1, so we're now left with plus ln 3. And so this now becomes ln of the mod of 1 plus y over 1 minus y equals to, and now using the addition law for logarithms on the right hand side, we now get ln of the mod of 3 times 1 plus x squared. Now if we apply e to both sides, we end up with 1 plus y over 1 minus y, which equals to 3 brackets 1 plus x squared. And so this now becomes 1 plus y over 1 minus y equals to, and now expanding the brackets, we get 3 plus 3x squared. Now timesing both sides by the denominator, we end up with 1 plus y equals to 3 plus 3x squared, and then in brackets, we now have 1 minus y. And now we get 1 plus y, then expanding the brackets here, 3 times 1 gives us 3, 3 times minus y gives us minus 3y, 3x squared times 1 gives us plus 3x squared, and 3x squared times minus y gives us minus 3x squared y. Now taking away 1 on both sides, 1 minus 1 becomes 0, and so we're now left with y. 3 take away 1 is 2, then we have minus 3y plus 3x squared minus 3x squared y. Now if we add 3y to both sides, we end up with y plus 3y, which is 4y, and then 2, and then minus 3y plus 3y becomes 0. Then we have plus 3x squared minus 3x squared y. Now adding 3x squared y to both sides, we have 4y plus 3x squared y equals to 2 plus 3x squared y. The minus 3x squared y cancels. Now if we factorize y from both terms, we end up with y brackets 4 plus 3x squared, and that equals to 2 plus 3x squared. Then dividing both sides by the bracket, we end up with y equals to 2 plus 3x squared all over 4 plus 3x squared. And this is the particular solution to the differential equation in this question.